This was our main definition in the previous video of what a function is. Let me emphasize one important point here. The fact that each value in the domain gets a unique value, f of x. And so what this leads us into is the notion of the vertical line test. So a graph represents a function if and only if it passes the vertical line test. Every vertical line intersects the graph at most once. So let's draw an example. Let's draw two different examples. One is a function, one is not a function. So here, this is not a function. X and y here. Why is this not a function? Because it's failing the vertical line test. And graph represents a function if and only if every vertical line intersects the graph at most once. Here's a vertical line that intersects our graph twice. And so the thing is, let's say that this is like x equals 7 here. Well, which value are we associating with x equals 7? Are we associating this value, which is like 3? Or are we going to associate minus 3 with it? And so we try to associate both 3 and minus 3. Well, we run into the issue here. F of x needs to be unique. So this is not allowed. This is not a function because it's failing the vertical line test. But this is a function. And so note that there's, you can have, like at this horizontal line, we're intersecting the graph multiple times, and that's okay. But each vertical line intersects the graph at most once. So these are, that is a picture way for figuring out, do you have a function? What is a function? Okay, so that's a little discussion there. Let's also hit up the domain and range. So the exercise here is to find the domain and range of f of x, g of x, and h of x. Given here, so x squared, let's just do them in order here. F of x is x squared plus 1. I'm going to draw a picture of x squared plus 1. And so first off, the domain is going to be all real x. We can write that as this fancy r, or negative infinity to infinity, because we can plop in any x that we want to here, and that will be okay. As for the range, what are the allowable outputs here? Well, we will never get a number as output that is smaller than that is strictly less than 1. The outputs here, they start at 1 and they go up. So we could say here the range is going to be the interval from 1 to infinity, including 1 here. So that would be the range of this function. Okay, let's do part B here. G of x is the square root of 4 minus x squared. So let's draw a picture again. If you were to graph this, it looks like this. Oops. And so the thing here is that we can realize that the domain is, in this case, not all of R. The domain here is not going to be all of R. It's going to be from -2 to +2 inclusive. So that's why we put on the square brackets here. How can we tell that? Well, remember, we can't take square roots of negative numbers. We can't take square roots of negative numbers, so that means that we want 4 minus x squared to be greater than or equal to 0. Rearrange this, you want x squared to be less than or equal to 4. when is x squared less than or equal to 4? When x is between -2 and +2 inclusive. Okay, so that's what's that's going on here for the domain. As for the range, we can see the smallest output is going to be 0, and the biggest output here, when x is 0, we get square root 4 is 2. So the range is closed interval from 0 to 2. Okay, and then so finally, part C here, h of x is x squared minus 3x plus 2, all of that divided by x minus 1. So one thing that we can do is that you might not know how to like graph this or anything, but we can factor the numerator using like the quadratic formula or something like that, or just looking at it and factoring. And so the numerator factors as x minus 1 times x minus 2 divided by x minus 1. And this is great because we can actually divide out, we can cancel out those factors x minus 1. So it looks like the formula here is just h of x is x minus 2. But there's a little catch here. And what's the catch? In the original statement of the function here, x wasn't allowed to be 1. And we still need to make sure that x is not allowed to be 1. Even though we can plug in 1 into this thing, this is the original version here. So the domain is going to be all x such that x is not equal to 1. Now, as for the range, so plotting x minus 2 here, so it's a straight line. So it looks like the range can be all going off to positive infinity, going off to negative infinity. It looks like that we're the range here is going to be all real numbers, but once again, remember x can't equal 1. And so if x were to equal 1, you get -1 here. You have a hole in the range at -1. So the range is going to be all x such that x is not equal to -1. And really, I should be writing the range in terms of y here, all y, such that y is not equal to -1. So these are some examples for you to think about domain and range. This is going to be important because in the future we're going to be working with these kinds of functions to do calculus with them. We need to have a pretty good grasp as to what's going on in order to work with them.